NASA says its Voyager 1 probe, the most distant human-made object in the universe, is sending usable information to Earth again.
Voyager 1 has just sent back a chilling message from deep space, and it's got everyone talking. Given the countless stars and planets in our universe, we've wondered if there are other beings out there. Carl Sagan believed there might be as many as 1 million civilizations just in our galaxy. Since the 1960s, eager scientists have been hunting for signs from these possible distant neighbors, with Voyager 1 playing a crucial role in this thrilling quest. What terrifying secrets has Voyager 1 uncovered out there in the dark? Join us. Let us reveal what this brave old probe has found, the hidden realm beyond. The Voyagers get their power from devices that convert heat from radioactive decay into electricity. Each spacecraft carries 10 scientific instruments, including one to measure magnetic fields, a camera for taking pictures, analyzers for studying materials, and sensors for detecting particles and cosmic rays. With these tools, the Voyagers have conducted 11 scientific studies, sending back crucial information that helps us understand the distant planets and moons they encounter. Voyager 1 launched on September 5, 1977, and almost didn't make it because the rocket nearly ran out of fuel, but it was a success, and the spacecraft quickly overtook its twin, Voyager 2, making it through the asteroid belt between Jupiter and Mars. By April 1978, Voyager 1 was already sending back its first pictures of Jupiter. In March 1979, it surprised NASA by finding a faint ring around the massive planet and discovering 2 new moons. These discoveries gave us tons of new information and expanded our knowledge of the outer solar system. The journey of Voyager 1 wasn't just about seeing distant planets. It was about discovering entirely new regions in our own solar system. Voyager 1 did a fantastic job capturing clear images of Jupiter's large moons, Io, Europa, Ganymede, and Callisto, as well as the smaller moon, Amalthea. Just like the earlier Pioneer spacecraft, Voyager 2 also revealed that these moons were dynamic places, each with unique features. Voyager 1 brought back surprising details about these moons. For example, it showed that Io is covered in colorful yellow, brown, and orange spots and has many active volcanoes. These findings reveal that moons can have active, changing interiors, just like planets. But this wasn't the most surprising part. The photos Voyager 1 took of Europa showed a smooth surface with lines, suggesting it might be covered in ice and could have an ocean beneath. Further studies supported the idea that Europa might have a large underground ocean of liquid water, which could potentially support life similar to Earth's. On March 5, 1979, Voyager 1 got incredibly close to Jupiter, flying within 174,000 miles of the planet's stormy clouds. Saturn was next on the list. A year later, the spacecraft reached Saturn and started sending back detailed pictures of the planet with its rings, full of surprises just like Jupiter. As Voyager 1 approached Saturn, it was ready to uncover surprising discoveries that would change our view of the universe. The ring question. One specific task for Voyager 1 was to study Saturn's F-ring, a fragile and newly discovered ring. Using its advanced camera, Voyager 1 discovered 2 new moons, Prometheus and Pandora, which helped keep the particles in the F-ring organized. It also found a new ring, the G-ring, and took detailed pictures of several of Saturn's moons. The main part of Voyager 1's mission ended with these encounters at Saturn, and then the focus shifted to tracking the spacecraft as it continued its journey toward the edges of space. But that wasn't the end of its journey. Voyager 1 also captured one of the most iconic images in the history of space exploration. On February 14, 1990, 20 years before it would enter the unknown of interstellar space, the spacecraft turned around to take a picture of Earth from an incredible distance of 3.7 billion miles. This photo shows Earth as a tiny speck caught in a beam of sunlight, famously known as the pale blue dot. Among the many pictures taken that day, which included shots of the Sun, 5 other planets, and a grand view of our solar system, The pale blue dot stands out as a powerful reminder of our tiny place in the vast universe. And that's not the end of the story. In August 2012, Voyager 1 finally made its way into interstellar space. Isn't that amazing? The journey of the Voyager spacecraft continues to inspire us, reminding us how much more there is to discover beyond our world. Voyager 1 is a spacecraft that has traveled far beyond the protective bubble created by the Sun, called the heliosphere. This area is filled with particles and magnetic fields from the Sun. Scientists realized Voyager 1 had left this region when its instruments detected a solar flare between April 9th and May 22, 2013. The flare caused the electrons around Voyager 1 to vibrate, revealing that the space it was traveling through was denser than the space inside the heliosphere. This was surprising because space far from any star is usually emptier than areas close to a star. Through careful analysis of Voyager 1's past data, scientists found out that it had actually left our solar system on August 25, 2012. They confirmed this by studying changes in electron movement and the solar particles recorded by the spacecraft. On this significant day, which also happened to be the day Neil Armstrong, the Apollo 11 astronaut, passed away, Voyager 1 detected a big increase in cosmic rays from outside our solar system and a sharp drop in solar particles. By then, it was about 11.25 billion miles away from the Sun. Managing energy has been crucial for Voyager 1's journey. The mission team turned off the cameras shortly after taking the famous pale blue dot image because capturing light in deep space is difficult. They also turned off 5 other scientific instruments to save energy. In November of the previous year, Voyager 1 stopped sending data back to Earth, meaning it couldn't collect new information. Fixing issues with Voyager 1 is a big challenge because of its distance. It's about 15 billion miles from Earth. Communicating with Voyager 1 takes 22.5 hours for signals to travel one way, making every interaction a lengthy process. Voyager 1 faced unexpected challenges that pushed the boundaries of what we could achieve in space. Voyager's long-distance puzzle. But that wasn't the worst part. As Voyager 1 continued its journey, it kept making amazing discoveries, but the distance also caused major operational challenges for NASA. Over the past several months, NASA's team has been working hard to solve a problem with Voyager 1 that started in March. NASA used a clever technique similar to a dentist's quick air puff to find cavities. They sent a command to Voyager 1 to perform a self-check. This check showed a malfunction in one of its 3 main computers, which is essential for gathering and sending data back to Earth. Instead of working correctly, the computer was sending back meaningless sequences of ones and zeros. No way to fix the broken hardware from billions of miles away, engineers had to be creative. They couldn't move the faulty code to a new location because of limited space in the computer's memory. So they came up with a solution to divide the problematic code into smaller pieces, manage them individually, and find different areas within the system to relocate these segments. This ensured that Voyager 1's mission could continue. Updating a spacecraft's software is no small task. Imagine trying to rearrange all the books on a shelf so that they not only fit perfectly, but are easy to grab when you need them. This is exactly what NASA's Jet Propulsion Laboratory had to do with the Voyager spacecraft. They had some exciting news. They managed to update Voyager's software from an incredible distance. They fixed a technical issue without needing any new hardware, which is a first in space exploration. This is the longest distance software update ever done. As scientists and space fans wait for new discoveries from Voyager 1, excitement is building. What new things will Voyager discover? How will these findings help us understand space better? These questions keep the team excited and capture the public's imagination as we all look up at the stars, dreaming about what we might find next. But this wasn't the most surprising part. The reason for the glitch in the spacecraft's chip is still unknown. It might have been caused by a high-energy particle from space, or just old age after 47 years of operation. NASA is still looking into whether the cause was something from the Sun or deeper in space. Over the years, Earth has sent strong signals into space to try and reach extraterrestrial beings, and has also picked up some strange signals, like the WOW signal. Ohio State University's radio observatory, called Big Ear, started searching for signs of alien communication. They were looking for significant signals among the cosmic silence. Then, on one memorable night in August 1977, they picked up an unusually strong signal. Jerry Amon, an Ohio State professor and a volunteer at Big Ear, was used to reviewing the data from the observatory's computer. A bike messenger would deliver stacks of computer printouts for him every few days. Usually, this data showed a dull background hum, but on August 18, 1977, Amon saw something extraordinary in the data from 3 days earlier. Instead of the usual numbers, there was a sequence of letters and numbers showing a radio signal 30 times louder than normal. Excited, Amon circled the sequence 6EQUJ5 in red and wrote "WOW." This event, now known as the WOW signal, is one of the strongest signs we might have encountered an extraterrestrial signal. It lasted just 72 seconds, but its unique characteristics have led many to wonder if it came from an alien spacecraft. But this wasn't the only intriguing part. A mysterious signal once reached us, raising questions about what might exist beyond our understanding. The mysterious message from beyond the stars. Why do some people think this signal could be a message from beyond our solar system? First, there's the hydrogen line. The WOW signal was found at a frequency of 1420.4556 megahertz, which is very close to the electromagnetic wavelength of hydrogen. Scientists at SETI believe this frequency is ideal for interstellar communication. Additionally, the specific pattern of the WOW signal makes it even more interesting. The shape of a radio signal can reveal a lot, and in this case, it suggests it might come from a highly advanced source, possibly beyond what we currently understand. When the WOW signal was recorded by the Big Ear telescope, it started with a strength of 6. Then it quickly jumped to an E on their scale. This scale used letters for numbers higher than 9, with U representing the highest level at 30. After reaching its peak, the intensity fell back to 5. If you chart this progression, it forms a near-perfect pyramid shape, showing just how unique this signal was. The WOW signal was remarkable because of its very narrow bandwidth. Most cosmic radio waves, which come from stars and galaxies, spread out across a wide frequency range. However, the WOW signal had a focused frequency, suggesting it might have been made by an artificial source. This raised the intriguing possibility that it could be a sign of technology, either from humans or perhaps from extraterrestrial intelligence. The source of this signal is a big part of the mystery. The Big Ear telescope picked it up while it was looking at a part of the sky near the constellation Sagittarius. This area is close to the center of our galaxy, which is packed with stars. If an advanced civilization wanted to reach out, it would make sense to aim their signal at such a star-rich region. But this wasn't the worst part. We still couldn't replicate the WOW signal, and that often makes people doubt its origin. Some think it might have been a radio signal from Earth bouncing off space debris, or maybe an accidental broadcast from a secret military satellite. It could even have been a glitch in the Big Ear's computer system. The short duration of the WOW signal, which lasted only 72 seconds and never happened again, also confuses many people. If it was a message from extraterrestrials, why was it so brief and one time only? There's also a debate about the signal's strength. To send such a strong signal over the vast distances of space would need a very powerful source, perhaps something beyond even a Type 2 civilization on the Kardashev scale. This scale measures a civilization's technological progress by how much energy it uses. All these aspects make the WOW signal a key topic in the search for extraterrestrial life. Adding to this mystery is the discovery of an object that sends radio waves to Earth every 22 minutes and has been doing so for over 30 years. This object, called GPMJ 183910, might be a dying star emitting signals from its poles, even though it spins slower than expected for this kind of emission. But that's just part of the puzzle. Astronomers usually find signals that change quickly, so GPMJ 1839's steady 22-minute intervals are unusual. As stars age and become neutron stars, they shrink and become incredibly dense. NASA describes neutron stars as cramming billions of tons of matter into an area as small as a city. These stars can shoot out powerful beams of energy and light from their poles, like a lighthouse beam, visible to us only when it's pointed our way. With every signal from space, we wonder what it means for our place in the universe and the risks of reaching out. A beacon in the cosmic wilderness. Wow. Signals and similar findings keep scientists digging into mysterious cosmic signals and objects, helping us understand more about the universe's wonders. Meanwhile, Voyager 1 and Voyager 2, which no longer communicate with Earth, are traveling through space with the golden records. These records contain Earth's sounds, music, and images, and act as a message in a bottle for any intelligent life that might come across them, telling the story of humanity. The golden records contain specific details about Earth's location in our galaxy. This raises an important question. Should the Voyager spacecraft openly share Earth's position? In L. Ron Hubbard's science fiction novel, Battlefield Earth, being this open turns out to be dangerous. In the story, alien invaders called the Cyclos find Earth because of the information shared by Voyager. Earth is depicted as a remote star system on the galaxy's edge, an area the Cyclos haven't fully explored. They only discover Earth thanks to the Voyager data. When the Cyclos find Earth, they invade, releasing a deadly gas that wipes out most of humanity. They start stripping the planet of its gold and other valuable resources. This invasion is part of their usual operations, which include interstellar mining and controlling planets and galaxies with their wealth. As Voyager travels further into space, it still carries this potentially risky information. The cover of the Voyager Golden Record features diagrams, including a key map showing Earth's position in the galaxy. As the spacecraft sail through space, they hope to be found by a technologically advanced civilization. Given what we know about the galaxy and its many planets that might support life, some scientists think sharing our exact location could be risky. This openness might attract hostile aliens, like the Cyclos in Battlefield Earth. Although marking Earth's location was a creative and bold decision, revealing such detailed information might lead to unexpected dangers. But that's not the worst part. Future finders of this message might not accurately pinpoint Earth because of changes and errors over time. Yet the risk of drawing unwanted attention from space remains. The Voyager probes, with their maps and details about Earth's position, are still out there, accessible to any space-traveling race. This situation is both exciting and a little unsettling. On one hand, making contact with another intelligent civilization could bring amazing opportunities for growth and learning. On the other hand, it might also uncover dangers we aren't ready to face. This concern isn't just theoretical. In reality, broadcasting our whereabouts into space is a big decision with lasting effects. It prompts serious thoughts about our responsibilities and goals as we move forward in space exploration and seek interactions with other life forms. Are we ready for the outcomes of such an encounter? What can we do to make sure any interactions with extraterrestrial beings are positive, or at least not harmful, to humans? The ongoing mission of the Voyager spacecraft, carrying their golden records, is a powerful expression of human curiosity and our desire to connect beyond our world. It represents our search for knowledge and our hope for friendly relations in space. But this isn't the whole story. It also urges us to think about the information we share and the possible consequences of our actions on a universal scale. Are we risking too much by broadcasting our existence to the universe? Share your thoughts in the comments and don't forget to subscribe for more.